Hi everybody, in this lesson we want to talk about complex numbers, and we're going to talk about the definition of a complex number, what a complex number is as opposed to a real number. Now a complex number is a number of the form a plus bi, where a and b are real numbers and I is this imaginary number, the square root of a -1. Alright, so let's look and see if these are complex numbers. 2 plus 3i. I think if I asked you, is 2 plus 3i a complex number, most of you would say that's true. It's of this form, 2 plus 3i, and that's true. This is a complex number. How about -5i? Would -5i be a complex number? Well, my experience is that most students think that that is not a complex number until I put a 0 out front here. And if I think of this as 0 plus a -5i, then they say, oh yeah, that is going to be a complex number as well. So remember, if you can write the number a plus bi, if you can write it in that form, 0 plus a -5i, then that's a complex number. Well, how about the number 4? Well, again, most students would think that's not a complex number until I write it like this, 4 plus 0i. And it comes as a little bit of a surprise, but in fact that is also a complex number. In fact, from this last example, you can see that every number that's a real number is automatically also a complex number. So the real numbers are actually contained within the set of complex numbers. So just as a brief review of our numbers, you know, the very first numbers that we learn, we call those the natural numbers. Those are the numbers like 1, 2, and 3. We like those numbers. And then if you throw in the number 0, you get what we call the whole numbers. There's only one more number in that set than in the natural numbers. And then if you throw in the negatives, like -1 and -2 and -3, then you get the integers that we use the letter Z from the German word for integers, and that denotes the set of integers. And then if I throw in the fractions, then I get the rational numbers that we use the letter Q. So this would be numbers like a half and -1/5 and so on. Okay, so all the fractions. And notice that every integer is also a fraction, right? Because you can write -1 as like -1/1, or you can write -2 as -2/1. And all the whole numbers, and likewise all the natural numbers, those can also be written as rational numbers, ratios of whole numbers, okay, or ratios of integers. So if I throw in the irrational numbers, then together all of these numbers right here are what we call the real numbers. But there's one set bigger than that. That's the complex numbers. And so the complex numbers contain all of the real numbers. Another way to look at that is to think of the numbers on the number line. Now the first numbers we learned were 1, 2, 3, 4, and so on. Alright, those are my natural numbers, my counting numbers. And if I throw in 0, then I get the whole numbers. If I throw in the integers, then I get the positive and negative nice numbers, as my students like to call them. And then if I throw in the fractions, then there's a whole bunch more dots in here, right? Between every dot there's another dot, so I can just average two numbers and get another rational number there. Alright, so here's like 3 1/2 and 3 1/4 and 3 1/8, and there's going to be dots just all over here. And there was a question for a long time if that was all the numbers there were. It seems like they just sort of flow into one another, but it turns out that that's not all there are. It's only when you throw in the irrational numbers that you end up plugging all of these holes that are left, and then you get the real numbers that you can think of as this line where each number flows into another one. Alright, so those are the numbers that we've come to know and love. Those are our real numbers. But that's not all of them. We have this other set of numbers, and if I were to draw another axis going up through 0 here, then I could call this the imaginary axis. Okay, and then I could think of numbers, well, like here's the number 4, it's over here, and here's the number negative, well, I'll just do -1, -2i would be like right here. And then if I wanted the number 2 plus 3i, this would be 2, and then I could come up in the I direction. This would be the single number 2 plus 3i. So just as we represent real numbers as points on a line, we represent complex numbers as points in the complex plane. We call this the complex plane. So every point in the plane will be another representation of a complex number. And the complex number has a real part, in this case 2, and an imaginary part 3, one number. And so you can see that the world where we've been living in the terms of the real numbers is just this little bitty line, but we have all these other numbers out here in the plane that we can think of as representing the complex numbers.